So I have my graph, and we have a graph that has mass on the y and volume on the x, just like our data. And most of you, as you started to compare the three different liquids, you said that water is more dense than the other two. So let's talk a little bit more about what that means and how that relates to the graph. So let's start with the slope. Slope is the rise over the run. You can also think of slope as the change in y over the change in x. And if we look at what the variables are on the y-axis and the x-axis, we find that it's mass over volume. Well, that relationship of mass over to volume, that is the density. That's crazy. So what we do by finding the masses and finding the volumes, and plotting them and then finding the slope, we're actually finding the density of the different substances. That's why they rise up at different rates. So one of the things that we're going to ask you to do on your assessment is to look at a graph like this and figure out the slope. So let's just review that quick. Y2 minus Y1, so the change in Y's, over X2 minus X1. And as I'm looking at my data, I have any of these, I can pretty much pick any of the points on the line because they do make a straight line. So I'm going to go with some logical ones. This one looks like it crosses at a point that's easy to find. This one does as well. So I'm going to use those 2 points. So I'm going to call this one my point 2, this one my point 1. All right, so Y2 is going to be 8. And then Y1 is 4. And then my X2, my X coordinate for this second one is 16. And then my Y coordinate, my X coordinate for the first one is going to be 4. And I just realized that I actually made a mistake in there. So I'm going to make this correct. Actually make that a 2 because this is the 2 and the Y goes over 4, 2. So I do that calculation. 8 minus 2 is 6. 16 minus 4 is 12. And then I'm going to turn this into a decimal, and that's 0.5. And I also want to include the units because I'm taking the mass over the volume. So the density, or the slope, I should say, and also the density is 0.5 grams per milliliter for this substance. So if we give you a graph that has the mass versus the volume, and you have a straight line in it, or a linear relationship, you should be able to find the slope on that line and then recognize that that's the density. I actually did this with all of the data that students sent in. And so you can see how nicely everything laid out. Again, this is because I had anywhere between 10 to 20 different data points. And so things fit really, really well. And these are the different slopes. So we've got the slope here of water of 0.99. The actual density of water is 1.00 grams per milliliter. Well, that's pretty darn close. Methanol, the slope is 0.753. The actual density of methanol is 0.791 grams per milliliter. Again, not as close as the water, but also pretty close. All right, so for ethanol, the slope is about 0.773. The actual density for ethanol is 0.789. So you can see how they're pretty close, not exact, but this is another way we can see how good the data is we're taking this slope value, we know it's supposed to be the density, and we have an actual value to compare it to. The closer it is, the better the data collection went and the less lab errors we probably had, or that we were able to control, because again, lab errors are always going to be there. Another thing we want you to be able to do is work with density mathematically. And this is just using the density equation. Density is mass over volume. And you're going to need to be able to manipulate this. We will give you 2 of the variables and are going to ask you to find the third. So let's take a look at this example. So we've got density is 0.993, mass is 14.23. So a couple different ways I can solve this. First of all, I could just put these numbers in. Density is 0.993 grams per cubic centimeter, equivalent to the mass, or equal to 14.23 grams divided by the volume. All right, and then why don't you pause the video and then solve that, and then pick it up again when you solve it. So volume, in this case, you should get 14.3 or 14.33 milliliters. Sorry, I want to make it's clear so you can see what that number is. So it's 14. So if you're looking at yours and you're like, oh, my answer is kind of close to that. If you got 14.1, that actually means that you didn't enter things into your calculator correctly. You didn't rearrange the equation correctly. So what we need to do here is think of this as cross multiplication. So if I rearrange this, so the volume is equal to something. The volume is 14.23 grams divided by the density. So that's another way you can solve it, is rearrange that first and then put it in, or you can substitute, and as long as you do your math correctly, you're going to get the correct answer out of it. All right, on to the next thing. All right, the density conceptually. So we can make an easy statement that says water is more dense than methanol, but the question is, what does that really mean? And usually students will substitute the word weight, that water's heavier than methanol. But that's not entirely true. It depends on how much volume you have. So let's go back to our mass over volume. My pen's a little lagging there. And think about what each of these things mean. So if we think about the physical quantity of volume, what volume actually is the amount of space something takes up. And then we want to think about mass. Well, mass is just the amount of stuff that we actually have. So we're comparing these two things. And so density really is how much stuff we can fit in a given space. All right, so when we make the statement that water is more dense, what we're saying is, so water is more dense than methanol. I want to make this a clear statement. What we're really saying, if we want to talk about stuff and space, water is more dense than methanol. What really we're saying is water has more stuff. And I'm using this stuff very generally. This is really what we talk about in chemistry, is what is this stuff? Water has more stuff packed into the same amount of space. As methanol. Methanol has less stuff. So we're gonna have less mass. All right, and so the other way you can think about density is, you may have heard the question, what weighs more, a pound of feathers or a pound of bricks? Well, they actually weigh the same amount. They both weigh 1 pound, but what's going to be very different about them is the volume. It takes a lot more space. Those 1 pound of feathers is going to take a huge amount of space up versus the 1 pound of bricks, because the bricks have a greater density. All right, so let's work on how we're going to ask you to use this. So I want you to envision a balance, just like a teeter-totter, maybe that you played on as a kid, or you saw on the playground. And we're going to have two sides of our teeter-totter, or our balance is what we're going to call it. And we're going to work with two different substances. And the substances that we are going to work with, A is going to be methanol, and B is going to be water. And we're going to ask you different things about them. In the worksheet, you're going to work with different substances. So first question, what would happen to the balance if there were equal volumes of A and B? And when we say what would happen to the balance, either it's going to stay in balance, or it's going to tip so that the A side is lower and the B side is higher, or it's going to tip so that the B side is lower and the A side is higher. So that's what we're asking you about. So let's start with number one. What happens to the balance if we had equal volumes of A and B? All right, so equal volumes. If we put equal volumes, and let's say that volume, doesn't matter what it is, but I can say it's about 5 mils. If I put 5 mils of water on one side and 5 mils of methanol on the left side, 5 mils of water on the right. Let's write that neatly there, Miss Hom. What will happen to the balance? Will it balance out? Will it not balance out? Well, one of the key things is the only way the balance is going to be in balance is if the mass is the same. So you have to ask yourself, if I have the same volume, is the mass the same? The answer is no, it's not the same, because that's what we were just talking about with density. These things have very different densities. Methanol has a density of, I believe, 0.791 grams per mil, and water is 1.00 grams per mil. So those are the numbers we're going to work with. So you might be able to look at this and just say that, oh, well, if I have 5 mils of each one, water is more dense, which means that this is what's going to happen to the balance, because water has more mass in that 5 mils. And that is what's going to happen with this one. So I can give my reason as water is more dense. So the same volume of water has more mass. Than the methanol. All right, so I can answer it that way. I also could work with the numbers. I could actually say, okay, well, if I have 5 mils of water, and I'm going to erase this part right here, and I'm going to work on this. Let's start with the 5 mils of water. I know I've got the density equation. Density is mass over volume. And I know the density of water is 1. And I know the volume of water is also, 5. I need to go with the 5 mils there. 5 mils. Then I can solve for the mass. Get this out of here and make it easier to work with. The mass then is going to be 5 grams. So I have 5 grams sitting on that side. I do the same thing on the A side. Density is mass over volume. I know the density of the methanol is 0.791 mass over volume. Actually, I want to get that in there. So mass over the 5 mils. And then when I solve this one, the mass is going to be 3.95 grams. So now I can clearly see from those two numbers that B is going to have more mass, and therefore B is going to be lower. Okay, let's try the second one. Second one says, what would happen to the balance if there were equal masses of A and B? I'll let you think about that one for about a short time. All right, so if I have equal masses, I don't need to do much work with this one, because equal masses right away tells me that it will balance. Because it's mass that's controlling which end is going to go up and which end is going to go down. So those are going to balance. Okay, last one. What volume of A do you need to balance out 6 grams of B? Okay, so I'm going to draw a picture with this one because that helps me think about these things. So my goal is to have this in balance. All right, because it says I'm trying to balance it out. I know that I have 6 grams of B. That's what I know I have sitting here. I also know B is water. All right, what it's asking me for is what volume of A. All right, well, from this previous question, number 2, we said if they're equal masses, it will balance. So that means I need to have also 6 grams of A, which is methanol, and then it will balance. But the question's asking me for volume. So I need to do one more step. I need to figure out, if I have 6 grams of A, what is the volume? So I go back to my density is mass over volume. I know the density of the methanol, 0.791. I know the mass I need is 6 grams, and I'm solving for the volume. And once I plug that into the calculator, Again, if you want to pause the video and then try it on your own, make sure you're entering incorrectly and start it up again. That volume is going to be 7.59 milliliters. That's the amount of milliliters. And if you think about, if you want to look at these two numbers, they do make sense because we know water is more dense. So to have the same mass, we need less volume of that water and more volume of the methanol because I would need, I want to have those same masses. All right, that should help you get started on that worksheet. Don't forget to email us if you're having any questions with it.